Hi everyone, it's Miss Landis. I'm here today with a science video for you to introduce Unit 7, which was sent home in the contingency packet. Unit 7 is all about rocks and fossils, which is something we didn't even touch the surface on in class. So it might be a little bit difficult, and that's understandable. So I decided to make these videos to go through the text and explain some important points. And go over how you can answer some of the questions, show you some examples, and all of that. So we're going to start off with kind of discussing what Unit 7 means overall. We're going to discuss the vocabulary words, which you do not have these pages with the unit opener and the vocabulary. You don't have those pages. However, I'm going to show you the page and just go over some of the words, and we'll go over them too as they come up in the text. Then I'm going to review and read through pages 456 to 461 and show the answers to the questions 1 through 8, but not number 7. Number 7 was not one of the questions that you were supposed to answer. So I wish I had this idea sooner so that you could watch my video and follow along with it and then pause it to answer the questions, then check your answer with me. So going forward in the future, the videos will just all be posted so that you'll be able to do that. But if you already completed 1 through 8, then you can use this video to just check your answers and go over some things and have me explain it to you. Okay, so let's get started. So this is a page from my book, so it looks a little bit different than how your book would usually look. But all of Unit 7 is about rocks and fossils. So I thought this was important, the unit overview, that you as a student, or if you're a parent watching, this is what your student or your child should be able to do by the end of the unit. Throughout the unit, we'll explore the different layers of rock and how they change, discover what we can learn about fossils and ancient environments, and identify patterns in fossils. So those are some of our goals throughout the unit. In looking at the image, some of us might not be familiar with fossils and archaeology, but fossils can tell us information about the past, like what animals were like on Earth and what the weather was like back then, and that's how we know about previous creatures that are extinct and don't exist anymore, like dinosaurs, or like a saber-toothed tiger or a woolly mammoth. Their bones were fossilized, and that's how we were able to understand that they used to walk the earth. Fossils are discovered by archaeologists. They make it their career to discover them by digging and excavating the earth. So question for you, do you think that this archaeologist is moving quickly through all of these rocks to discover fossils, like he's just kind of like digging up whatever, or do you think he's moving more slowly throughout the process and delicately? Hopefully you would think that he's moving slowly, right? Because archaeologists have to work slowly and carefully so that they don't damage any fossils that they come across. They want to make sure that everything stays in as nice of a condition as possible so that they can study it. So I'm going to turn the page and we'll look at some of the vocabulary words that we'll see. Our unit vocabulary, the first word is, and I'll kind of get this down here a little bit closer. The first word is aquatic fossil. An aquatic fossil is the remains or traces of an organism that lived in water long ago. And a good way that you can remember that is the word part aqua means water. So anything aquatic would be coming from the water. I'm sure most of you have been to an aquarium before. And obviously in an aquarium there's a lot of water and creatures that live in water. If you can think of any other words that have aqua in them, send it to me on Dojo because I would love to hear if you can come up with any more of them. Or you can comment on the video too. Extinct describes a kind of thing that is no longer found on Earth. So if something is extinct, like an animal or a plant, it means that it used to live on Earth but not anymore, like dinosaurs or woolly mammoths. A fossil is the remains or traces of an organism that lived long ago. Something that you could do as an extra activity to extend your knowledge is to just look up pictures of fossils, because it's really cool to see what types of animals or even plants have been fossilized and what they look like. And I do have an activity that I could post in our Google Classroom if you're interested in extra credit, so I'll kind of talk about that later down the line. Relative age is the age of one thing compared to another. So relative age, I think, is probably the most difficult word to understand, and I get it because it's kind of a hard concept. But relative age is even when we just use the word relative in general, we are comparing two things in order to form an opinion. So when we're talking about relative age, think about how old you are. You're probably 9 or 10. How old are your parents? Maybe they're late 20s, in their 30s, maybe even younger. So if you look at you compared to your parents, even if I looked at you compared to your parents, I would be able to determine a relative age, how old somebody is compared to another. So if I looked at you standing next to your parents, I would say, obviously, you are younger than your parents because you are probably not as tall. Or, some of the other features, like maybe like your hands are smaller or your feet are smaller. So as you grow, you're going to look older. If you compared me to my grandmother, you would be able to determine that my grandmother is older. That's relative age. So that's how we kind of determine how people are older or younger, but you can also use relative age to determine how plants are older or younger. If you saw a tree in the park and it only came up to your shoulders, you could compare it to another tree in the park that's so tall it's something that you can't even measure. You would be able to determine a relative age that the one tree is younger than another tree, and what scientists do is they determine the relative age of trees when they look inside of them and they look at the rings around the trunk of the tree, and the more rings the tree has, the older it would be. So that's how they determine relative age in trees. And then relative age can also be determined in fossils when you're looking at what type of rock it is, or even where the fossil is at in a rock structure. And we'll get into that later on in the chapter as well. A terrestrial fossil is the remains or traces of an organism that lived on land long ago. So aquatic fossil, water. Terrestrial, land. And terrestrial has another word part in it that helps us understand that it is from land. Terre, T-E-R-R-E, is the word part, which means land, or earth. And how perfect is that? It's Earth Day, and we're talking about the Earth. So happy Earth Day, everybody. Another word that I can think of that has this word part terre in it is terrarium. So if you've ever seen a terrarium, they're actually really cute. They have like mini plants in them and rocks like in a glass. And like people can make them themselves or you can buy them. They're super cute. So if you know another word that has this word part in it, you can even Google it and then comment below or send it to me on Dojo, and I'll give you extra credit for science too. And I mean, it's like a fun way to learn about words as well. Throw language arts into science. So let's get started now that we're done reviewing our vocabulary. So we're going to read through lesson 1 and answer the first set of questions. So lesson 1 begins on page 456, and this is just the first part of lesson 1. I'm going to do the next part in a separate video so that the video is not too long, and I'm hoping that you at home aren't doing like so much in one day. You should be breaking it up so that you don't overwhelm yourself with too much work, because I don't want that to happen to you. All right, how do rock layers change? Rocks can give clues about things that happened on Earth long ago. They can also provide evidence of how our planet has changed over time. Some of these rocks formed in ancient oceans. That would be aquatic. Some of them formed on dry land. That would be terrestrial. What else might rock layers tell us about the past? Your goal by the end of this lesson, so not really by the end of today, but by the end of this overall lesson, which is broken up into a few days, is you'll be able to determine the relative age of rock layers and explain how rock layers change. So remember, when we're talking about relative age, we want to be thinking about comparing one thing to another to determine age. So you don't have to know, like looking at a rock, I know that that rock is 100 million years old. No, we just want you to know, looking at a rock structure, what layers in the rock structure are the older layers and what layers are younger. I have highlighters with me just in case I want to highlight something important. So if you want to stop and get a highlighter and highlight along with me, you can. Or you can use your pencil or a pen to underline. All right, our first question. So whenever there's a question at the beginning of a unit when you haven't learned anything really yet or read too much about it, it's always just to gauge your knowledge, which means to see how much you already know and how much room you have to learn new things. In looking at this picture here, I'm going to read the caption and then talk about how you can answer this question. Look at the photos. Rock like this can often contain fossils within its layers. Fossils form when ancient living things die and become preserved in rocks. Fossils are found in some types of rocks. Okay, take that in. Understanding that we can find fossils preserved in rocks after creatures die. Number 1. The rocks in the photos belong to a group of rocks called the Niobrara Chalk Formation. How do you think these rocks formed? Which rock layer is the oldest? Which is the youngest? So I would try this yourself, so pause the video, think about how to answer the question. Don't forget to use a complete sentence. So they're asking you 3 questions. How do you think these rocks were formed? Which rock layer is the oldest? Which rock layer is the youngest? So go ahead and give that question a try. So in looking at the question, this is a what do you think question. So there's really no right or wrong answer here in the first question being asked. How you think these rocks were formed. So in starting off your sentence, you can say, I think these rocks were formed by, and I'm sure you guys have a ton of different answers, which I would love to see. I really would love to see like what some of you guys are doing in your science packets if you want to send me pictures, because I miss you and I miss your amazing answers so much, and I want to know like what you guys are doing and how you're answering these questions to kind of see if you're getting it and understanding. So if you have time on Dojo, send me pictures so I can, see what's going on with you. And there's really no right or wrong answer here, especially because we didn't do Unit 6 together, which is all about Earth's surface. So some of that knowledge that you might need to answer this question, you might not have yet. But you could even like use Google too to help you if you feel like you're confused with some of this stuff. Something that I would guess would be like my using previous knowledge that I know. I think about the Grand Canyon is a huge rock formation, and I've never been lucky enough to go there, but my sister has, and she has a bunch of really cool pictures. But the Grand Canyon was formed by the Colorado River, by water. So rock formations, in my knowledge, what I know is that they can be formed by water, and they can also be formed by wind. So that would be my two answers, that like I think these rocks were formed by water or wind. And basic knowledge of understanding the relative age of rock layers is that the oldest layer is on the bottom and the youngest layer is on the top. And I know I'm like writing on my page, but you can't really read it. But the oldest is on the bottom and the youngest is on the top. And there's a good information in the next few pages to help you understand why that is. So, which rock layer is the oldest? The oldest rock layer is on the bottom. The youngest rock layer, why did I put a period there, is on the top. And you could have had anything for how you think that they're formed. Like, that's just a kind of like an educated guess for you. Okay, so let's move on to the next page. And we have some cool rock formations to look at. And also, I'm going to just send out a reminder email and put it on Class Dojo too, that you can log into your science book online, and then you can kind of see the pictures so much better, because these rock formations, I mean, the pictures are very pretty in the book. A lot of them have awesome colors, and you can see the layers a little bit better. So I'll kind of let you know how to log into that, because that's something that we hadn't done too many times in class. I think we might have done it once. Okay, so look at these photos. These photos show rocks in places from different parts of the world, yet all the rocks have something in common. Study the photos and then answer the question. So we'll be answering number 3 down here. So our first one is Aqua Head, and it's in New Zealand. I should just kind of start from the beginning. Aqua Head is in New Zealand, an island nation not far from Australia. So Australia is like halfway around the world. These rock layers have been changed by the ocean and the wind. So they're going to tell us how some of these rocks are formed, and it can help you look back at your answer for the previous question. So, I mean, I'm your teacher, so I should know that water and wind can shape rock formation. So that's why that was my answer. So that's pretty cool that water and wind was able to form kind of this circular rock. It has kind of like little divots in it. And something that I notice is the layers are going like this. Like, I can trace over those lines and see the different layers of rock. I'm going to highlight these rock layers have been changed by the ocean and the wind, because I think that that's an important statement to help us understand how rocks are formed. Next, the Alps are mountains that stretch across Europe. These mountains are made of many layers of different types of rock. Once again, I can see, and very faintly in the packet, but I do see the lines that are going across. And you can kind of trace them with your pencil or even your highlighter. Antarctica's Buckley Formation formed almost 300 million years ago. Some of the rocks in this formation include coal, a rock that formed in ancient swamps. So that's pretty cool, because thinking about coal, and if scientists know that it's a rock that formed in ancient swamps, what do you think the land was like that many years ago if they found coal? Well, if it's kind of a dry climate now, maybe it used to be wet and moist like a swamp is. So that's how we can learn about climate, through the rocks and fossils. And the next one, the rock layers surrounding this waterfall are near Stony Creek, Ontario. Ontario is in Canada. The rock layers show many different colors of rock. So unfortunately in your picture you can't see it, but the picture of this is really pretty with different colors, and you can really see the layers of rock. So I forgot to highlight in this picture, or kind of underline, that we can see very faintly the layers going across. You can really see them going across in this picture. And by across, I mean they're going like this. That would be horizontal. None of them are going like this, which is vertical. So we see the rocks going like this. So that's going to help me answer the question. Explain how all the rock layers shown on this page are the same. Well, they're all the same because they're all going from side to side across. They're all going horizontal. So that might be a new word for you, but I'm going to use it in my sentence to be fancy. Each formation also has layers that sit on top of each other, and that's how we can determine the relative age. So in this rock formation, down here would be the oldest rock, and up towards the top would be the youngest layer of rock. So I'm going to say each formation has layers. Has layers that sit on top of each other. And I'm going to say all the layers look horizontal. And that is my answer to that one. All right, moving on. Now we're going to talk more about these layers. And I like this example because I feel like it really helps you understand it. How some rocks form. Many cities across the United States have recycling programs in which used items are collected and used to make new items. Read on to find out how recycling newspapers is similar to the way a series of rock layers can form. Now, I don't really see people recycling newspapers like this anymore, but the example does really help you understand why the oldest layer is at the bottom, which I like. So on day one, a family drops a newspaper into a large recycling bin. So here's the bin, and here's day one's newspaper. The newspaper falls to the bottom of the bin as it's thrown in. You can think about anything like this too, like when you're throwing stuff in a trash can. Like when you just put like a new trash bag in a trash can and you throw the first piece of trash in, it's going to have been in the trash can for much longer than whatever is on the top of the trash can before you take the bag out. So that's just like the newspapers. On day two, another paper is put into the bin. The family drops one newspaper into the bin each day. Label the missing days on the bins below. So in order to figure out what day it is, you have to count the layers. So I was able to look at the corner right here and count 1, 2, 3, 4, 5 corners. So this would be day 5. And then when I counted this one, I was able to count 9. So that's day 9. Number 5 says, think about the newspapers in the recycling bin. Which layer is the oldest? Which layer is the youngest? The image below shows the papers on day 9. Circle the youngest layer and draw an arrow to the oldest layer. Put an X over the layers that are not the oldest or youngest. So I'm going to use my different colors here. So first, we have to circle the youngest layer. The youngest layer is on top. Like if this was day 9, this would be day 9's newspaper right on top. So it's the youngest one. It's hard to circle, so I think I'm just going to color it. So if you want to do that, that's fine, because it's really hard with the way that it's copied. Or you can draw an arrow to it that says youngest. Whichever you decide to do is fine, but circling it seems pretty difficult. All right, and then the bottom layer is the oldest newspaper because it's been in there the longest. And then we can just put an X on all of the other ones. They are not the oldest and they are not the youngest. If you are a middle child, then you can relate to that. Not being the oldest or the youngest, you're stuck in the middle. All right, let's turn our page. And we're going to talk a little bit more about relative age in using the newspapers. So scientists can tell the relative age of rocks by looking at where they fall in a sequence. So the sequence meaning like looking at the layers from the bottom to the top. Relative age is the age of one thing compared to another. Like I said, determining the relative age of a human, you can compare that human to other humans. What do you know about height? The way their skin looks. Like you can, I mean, looking at me, I know I just look so young compared to some other people. And it's probably just because I'm short. But I'm also not that old. So if you were looking at my mom or my grandma, they might have like some wrinkles or maybe their hair is gray. So that's one way that you would be able to determine somebody's age in comparing them to somebody else. In rocks, when we're looking at what's older or younger, we look at where it's falling in the formation. The oldest rock is going to be at the bottom, and the youngest rock is going to be at the top. So look at your answers to question 5. How did you know which layer was the oldest and the youngest? So at this point, I've been saying it a lot, so hopefully we're getting it, that we knew that the paper for day 9 was the youngest because it's on top. It was just recently thrown in there. We know that the paper from day 1 all the way on the bottom is the oldest because it's been in the bin the longest. Just like humans, if you were just recently born, you haven't been here as long as somebody who was born like 50 years ago. They've been around longer. They've been in the bin longer than whoever is here more recently. So make sure you restate your question. I knew layer 1 was the oldest, which is the one on the bottom. I'll say I knew the layer on the bottom was the oldest because it was the first put in the bin. So that's our evidence. We'll say day 9's paper is the youngest because it was the last in the bin. So your answer should look something like that. We're skipping number 7, so it's not circled in your packet, so don't do it. Wrapping it all up. I love the putting it togethers because I really think that they always just encompass the most important takeaway from the lesson. So we do have 4. They love to do this to us. We have 4 blanks and we have 5 terms. So one of them you're not going to use. In a sequence, and I always read through the whole thing first. In a sequence of rock layers, the oldest layer of rock is blank of the sequence. The youngest layer is blank. As the layers form, blank rock forms on top of blank rock. So the oldest layer of rock is on the bottom. So at the bottom. Gosh, you have to write so tiny for this. The youngest layer is at the top. As layers form, blank rock forms on top of blank rock. So we're not using the term in the middle. That doesn't make sense. As the layers form, in the middle rock forms on top of younger rock. I don't know. So that one we're not using. We're using older and younger. So what forms on top? The younger rock forms on top and the older rock on the bottom. So younger rock forms on top of older rock. And that wraps up kind of the first section. This would be about a day's work. So this video was a half an hour. So what my goal is for you is to not really be spending more than just a half an hour of science a day. If you're doing like how we do in class, like science one day, social studies another, then for your science day, maybe an hour's work instead of a half an hour. So I hope this video is really helpful, and there's going to be a video for each section to break it up and help you out and answer maybe some questions or describe things that are confusing. If you have any questions, reach out to me and ask me. And then, like I said about the vocabulary, if you have any words that have aqua or terre in them, which means earth, then let me know because I'm very interested in seeing what you come up with. All right, have a great day.